Hey everyone, how it goes and welcome back to Computer Science 145. Today, we're going to talk about loops. Today, we're going to talk about loops. Today, we're going to talk about loops. Today, In a previous lecture, we discussed flow control, and we focused on branching statements. Another element of flow control is called a loop statement, and this one repeats an action until a stopping condition occurs. One of the most essential looping statements is called the while loop. Now, in a while loop, if the Boolean expression evaluates to true, then the body of the while is executed until it is false. Much like branching statements, it's a really good idea to put the curly braces to denote the body of a while loop. Also, very similar to branching statements like an if statement, do not put a semicolon after the parenthesis of the while loop. Now, as we are learning how to communicate with the machines, you can think of a while loop as being spoken as, while this is true, keep doing that. Now, over to the side here, we have the syntax for a while loop. Notice that it looks very similar to an if statement. Now, while the Boolean expression is true, we keep running the body of the while. Once that Boolean expression evaluates to false, we jump outside of it and keep going on. So our example right here is if we go ahead and create this integer a and assign it the value of 0, while a is less than 10. So let's look at this. While 0 is less than 10, system.out.println a. So it prints out 0 and then increases by 1. So then a becomes 1. 1 is less than 10. Print out 1. Increase it. 2 is less than 10. 3 is less than 10. 4, 5, 6, 7, 8, 9, 10 is not less than 10. And so we immediately jump outside of the body of this loop. Just like branching statements, we can represent a loop using a flowchart. And this is what they look like. So we have the syntax over here, and we enter through here. By the way, this little circle, this is simply a connector. I'm only adding this for clarification. This really doesn't do anything, and you don't have to put this in your flowcharts. It just makes this example a little cleaner. So now, once we enter in through here, we evaluate this Boolean expression. If this is true, then we run the body of the while, and then immediately go back up and check the Boolean expression again. If that's true again, we run the body of the while. Going back up here, check the expression, run the body of the while, go back up here, and we keep doing this while this is true. Now, once this evaluates to false, we immediately jump out of the while loop and continue running the rest of the program. Now, one element that might be very subtle is this. If we initially go into this and check this Boolean expression, and it's initially false, the body of the while will never run. We will simply just jump out of this and then go outside the body of the while. Now, let's see an example of a while loop. Now, the problem that we are addressing is we're going to create a game, and this game is going to be a number guessing game. So the idea is this. The program is going to randomly pick some sort of value, and then the user has to continue guessing until they get the value correct. The program is also going to indicate to the user whether or not their guess was higher than the secret number, lower than the secret number, and if they guess it completely right, then they win the game. Now let's go ahead and start this. We're first going to create a new class, and I'm simply going to name it number guesser, and we're going to include the entry point, the main method. After that, I'm going to make sure in a comment to write my name. Now, as mentioned in the description, we need to have some kind of user input. So once again, we're going to import java.util.scanner. That way we can use the type scanner to gain input from the console. It was also mentioned that the program needs to pick a random number. And so we're going to also import java.util.random so we can use the type random in order to pick a random number. Now just taking out that auto-generated comment, we're going to enter into the entry point, the main method. The first thing I'm going to do is create an instance of that scanner, that way we can gain user input. Scanner keyboard equals new scanner system.in. Now just like the scanner, we need to create a random number generator, so we're going to create a random r equals new random. Once we have this, the program needs to pick a random number. So we need to create a variable, and we'll just say int secret number is equal to r.nextInt. We also know from a previous example that this r.nextInt is going to pick from any integer value. Maybe we want to keep this simple and only pick the values from 0 to 99. In order to do that, we need to add an argument inside of this r.nextInt that basically gives the range of values. I would argue this range would be constant. So, outside of the entry point, we're going to go ahead and create a public static final int upper number and assign that to 100. Now, inside the arguments of this method, we're going to go ahead and call upper number, which is going to pick the values from 0 to this number exclusively. So that means it will pick the values from 0 to 99. Now we're going to prompt the user. System.out.println. I'm thinking of a number from 0 to upper number. Then we're just going to put an inline to format this nicely. Guess the number. Now once we've prompted the user, we have to create a couple more variables in order for this to work. So I'm going to create an int guess number and just assign that to 0. This could be assigned to anything, but it's a good idea to create an initial assignment. Now after that, we're going to create a Boolean correct guess, and I'm going to initially assign that to false. As we have not started the game, we haven't been able to guess the correct number yet. Now right after that, while not correct guess. Reading this out loud, while we have not guessed correctly, we're going to keep running what's inside the body of this while loop. And also, just pointing this out, we initially assign this to false. When we not false, it becomes true. So, while this is true, we now enter the body of this. Now we allow the user to guess the secret number. So we're going to reassign the guess number is now assigned to keyboard.nextInt. Once we have their guess, we need to be able to tell the user whether or not they guessed too high, too low, or guessed the exact value. All of these are decisions. So once again, we're going to utilize branching statements in order to do this. So if the guess number that they just entered in, if that value was greater than the secret number, then we need to prompt the user that system.out.println, that's too high. Now, if this was not true, then maybe they guessed too low. So this is why we create an else if the guess number was less than the secret number. Now in this case, we have to prompt the user system.out.println, that's too low. Now, if the guess number was not greater than the secret number, and also it was not less than the secret number, then otherwise, we've guessed the correct value. System.out.println, that's correct. But now we also have to make sure that we change correct guess is equal to true. Because we have guessed the correct value, this will jump back up to here, this will be false, and then we jump outside of this while loop and the program ends. So let's go ahead and test this out. Running this, I'm thinking of a number from 0 to 100. Uh-oh. There's a slight bug, because here's the deal. This r.nextInt picks the numbers from 0 to 99. So all I need to do to make this work is going to this upper number. I'm going to put this inside a parenthesis and simply subtract 1. Now let's run it again. Ah, that's correct. I'm thinking of a number from 0 to 99. Let's guess this number. You know what? Let's start right in the middle. Let's guess 50. Okay, 50 is too high, so let's try, 12. Okay, that's too low. Let's try 23. Okay, that's also too low. Let's try 40. Okay, that's too low. So let's try 48. That's too high. 46. Ah, that's correct. However, notice what happened here. Until we had the correct guess, we kept running this code over and over and over and over again until the correct guess was reached. Let's also take a look at this example by using the debugger to see exactly how this is running. I'm simply going to add a breakpoint right here when we're basically assigning that secret number. Switching this to debug mode, we can see that everything now has been set up. Now I'm going to keep stepping over. So notice that our secret number is now randomly assigned to 87. Let's also keep a look at the console, because now we print out I'm thinking of a number between 0 and 99, guess the number. Now we declare and initialize that guess number to 0, and also declare and initialize the correct guess to false. Now, because not false is true, we enter the body of the while loop. Now, we wait until this guess number is entered, and let's go ahead and enter 50. Now inside of here, the guess number, 50, is 50 greater than the secret number? Is 50 greater than 87? No, that's false, so now we jump to the else if. Is 50 less than 87? That's true, so we print out that's too low. And now we go back to the start of the while loop. Correct guess is still false. Not false is true, so we enter the body of the loop. Now we have to guess again. For argument's sake, I'm going to guess 95. Now, the guess number is 95. Is 95 greater than 87? That's true. So we enter the body of the if, print out that's too high, and then start the loop over again. Then we enter the body of the loop. This time, let's enter what the secret number is, 87. Now, is 87 greater than 87? No. Is 87 less than 87? No. So now we enter the body of the else. We print that's correct. We assign correct guess to true. We jump back to the start of the loop and now not true is false. The Boolean expression is false, so we immediately jump outside of this while loop, and that ends the program. There's an alternate version of a while loop called a do-while loop. Now, unlike a while loop, the body of a do-while runs at least once, and then may not run again. After running the body of the do-while loop, if the Boolean expression is true, then the body of the do-while loop is executed until it's false. Now, just like all of the other statements, putting those curly braces is a good idea. That way you know exactly where the body of the loop is. Do-while loops are a little strange because they do require a semicolon after the argument. If you forget to put that semicolon, it will create a syntax error. So make sure for a do-while loop only to put this semicolon right there. Now, as we're communicating with the machines, this can be spoken as do that while this is true. Now let's take a look at this example. We assign integer a the value of 10. The body of a do-while loop runs initially. So this would system.out.println the value of a, so 10 would print out. Then we increase a by 1, making it 11. 11 is not less than 10, so this actually doesn't loop again. Now in contrast, if this happened to be a while loop instead of a do-while loop, well, it initially sets up as 10. 10 is not less than 10, so the body of the while loop would never run. However, because this is a do-while loop, the body runs at least once. We can represent a do-while loop using a flowchart as well. The major difference is the body of the do-while is run initially, and then the Boolean expression is checked. If this expression evaluates to true, then we run the body again. But if this is false, then we jump outside the body of the do-while. Now let's see an example of a do-while loop. Let's say our problem is this. We want to be able to calculate the factorial of some given value. The factorial of a value is multiplying that value times that value minus 1, times that value's value minus 1, times that value da-da-da-da-da-da. So let's go ahead and set this up. Creating a new class, and we'll just call this do while factorial and include our entry point, the main method. Next, we put our name at the top here, written by JJ Shepard. And I'm just going to go ahead and clean up the entry point there. Now, once again, we need some kind of user input, so we're going to import java.util.scanner. That way, inside our main method, we set up a scanner keyboard equals new scanner system.in. From there, we're going to prompt the user. System.out.println, enter a value 1 or greater, and I'll calculate its factorial. Now we need to create a variable to store that value. So int fact value is equal to keyboard.nextInt. Now, before we move on to calculating the factorial, there's something that we have to point out. Inside of this prompting the user, we have to have a value that is greater than or equal to 1. If the user were to enter the value 0 or some negative value, then we cannot calculate this factorial. We need to be mindful about error checking, and so in this case, if the fact value was less than or equal to 0, then system.out.println, that is not correct. And what we're going to do is immediately stop the program. System.exit. However, if this was not true, then we're not going to end this program. So now we're going to create some variables in order to calculate this value. I want to keep this value the same, and I'm going to create a copy of this that we are going to work with. So I'm going to create an int fact copy is equal to the fact value. And then the actual value of the factorial I'm going to set up as int factorial is equal to 1. Now we're going to create a do while loop. And right here we're going to put while this fact copy is greater than 0. Also, don't forget the semicolon right here. Now while that is true, we're going to assign factorial times equals the fact copy. And then we're going to reduce the fact copy by 1. So if we had entered the value 5 and we were calculating 5 factorial, this would cause it to be 5 times 4 times 3 times 2 times 1, and then we'll stop. Now once we're outside of this loop, we're going to go ahead and call system.out.println the factorial of the original input, fact value, is the factorial. Now running this to see if it works, we're going to go ahead and enter the value 5, and the factorial of 5 is 120. And 5 times 4 times 3 times 2 times 1 is 120. Now this is one of many different ways that we could calculate this value. We decided to use a do while loop in this case just so we could ensure that the body of that loop is going to run at least once. However, this can be easily done with a while loop as well. As we are learning how to communicate with the machines, I want everyone to start developing their programmer voice. One problem that comes up with loops is called an infinite loop. A loop's Boolean expression has to eventually evaluate to false, and if this doesn't happen, it creates a logic error called an infinite loop. The body of this loop keeps running until the program is eventually terminated. Infinite loops can be caused by a number of problems. Some of the most common ones is like an off by 1 error, using incorrect bounds, and even round off errors. In the example that we see over here, this first one has a problem with the bound. We initially declare this variable a and assign it to 10. Now 10 is greater than 0, so it keeps printing out the value of a. But notice this. A is then increased by 1. So then a becomes 11, 12, 13, 14, 15, 16, 17, 18, and it keeps going infinitely. The value of a will never be less than or equal to 0, so the body of this will keep running until eventually the program is terminated. An even stranger example is right here. Let's say we declare the variable double j, and we assign it the value 10. Now while j is not equal to 0, we subtract 0.1 from it. So why would this cause an infinite loop? Whenever we are using floating point values, in other words doubles or floats, we have to account for round-off errors. Even with this example, the value of j may be rounded off in a strange way. So it may never be exactly 0, even though logically it should be. Whenever we are using floating point values, it is better to use less than or equal to or greater than or equal to instead of just equal to. Because of these round-off errors, it may not be exactly equal to 0, and what can happen in this case, instead of it being exactly equal to 0, eventually it's going to be negative. And as it becomes negative, it just becomes more and more negative, and it will never reach the value of 0. Always keep in mind, floating point values like doubles or floats are imprecise. In addition, we can nest loops with inside of other loops. This is very similar to branching statements. However, whenever we are looping loops inside of other loops, these can be full of all types of logic errors. If you're encountering these types of logic errors, then draw out the logic using a flowchart. When we have nested loops, we can see them looking something like this. Over to the side there, we have a syntax. And now over here is how it can be represented. So entering this program, we check this first Boolean expression. If this is true, then we enter the body of this first while loop. Now remember, the body is indicated by the open and closed curly braces. As we enter the body of this while loop, we then check the second Boolean expression. Now let's assume that that was true. Then we are going to run the body of this inner while loop. And we keep running this inner loop until eventually this Boolean expression becomes false, and then we run the rest of the body of the outer while loop. Once we've run the body of this outer while loop, it loops back up to here and then checks this Boolean expression again. Assuming this is true, we then check this Boolean expression and keep looping this until it's false, then we loop back up. Now, once Boolean expression 1 evaluates to false, then we jump out of here to the outside of this outer while loop and continue on. Now, let's see an example of this. Now that we know about nesting loops, we can augment this previous example. Maybe we want to be able to give the user the opportunity to play this many different times. So, what we're going to do is loop the game until the user chooses not to play it anymore. This means the program is going to have the opportunity to pick multiple secret numbers and play the game multiple different times. We want to play the game at least once, so we're going to utilize a do-while loop to achieve this. We're going to create the do-while right here. So we start out do, and now we put this opening curly brace. Now with curly braces, parentheses, or anything of that sort, we need to be able to ensure that it has an opening and closing element. Jumping down a little bit, this is the entire guessing game that we want to be able to run multiple times. We're going to put the closing curly brace right here. Now, in order to clean up this code, what I'm going to do is highlight everything and simply by pressing Tab, indent it. This is a stylistic choice that makes the code a little more readable, because now I can easily see that all of these statements are inside the body of this do while. Now we need to write the while part of this do while. But before we do that, we're going to go inside the body of the do while, but outside the body of this while loop, we're going to prompt the user, system.out.println, enter true to play again. And then we're going to say Boolean play again is equal to keyboard.next Boolean. And now we're going to write the while part of this do while. While play again. So in other words, if this is true, then we're going to run the entire program again. However, notice something. There's a syntax error right here. But hold on a second. Inside the argument of a while or a do while, you need to have a Boolean expression. Well, we have this right here. So why would this cause a syntax error? As mentioned in an early lecture, whenever you declare a variable, that variable only exists inside the body in which it was declared. The body of this do-while loop starts here and ends here. Because this variable was declared inside of it, it doesn't recognize this variable value. This means we need to declare this variable outside of this do-while loop. Going outside the do-while loop, I'm going to redefine this. Boolean play again. I'm just going to initially assign the value to true. Now that way that we don't have a duplicate value, we take out the type here so it doesn't try to redeclare it. And now this works. Always keep in mind, a variable only exists in which the body it was declared in. This is true for do-while loops, while loops, if statements, else if statements, and else statements. So now, let's try out this new version of the game. Running this, let's start with 50. That's too high, so let's try 25. That's also too high. Let's try 12. That's too low. Let's try 15. That's too high. Let's try 13. And that was correct. Okay, I feel like playing again, so I'm going to enter true. And it starts over again. All right, guess number. I'm going to guess 50. That's too low. All right, let's go with 75. That's too high. Let's go with 60. All right, that's too low. Let's try 62. And that's too low. Let's try 63, 64, 65, 73, 74. And finally, we got it. Now I'm going to enter false, and we end the game. In this lecture, we introduced loops, and loops allow us to run statements over and over and over and over and over again until a Boolean expression evaluates to false. And with all that being said, I'll see you next time.